And I think we should be good.
Okay. Welcome back to another video code review from the VC Libs team. Today we'll be looking at a PR for the CS+20 feature improving variance, converting constructor and assignment. This PR was contributed by Michael Riscala. And let's see, so the PR links to the issue. As usual, we have filed one issue for every remaining feature being implemented. So we label those all with CX620. This links to the paper in question, 0608R3. I had in this issue, it's nice to be able to record extra information like, oh, this was patched by later papers, A, B, and C, or LWG issue resolutions, or like here's the feature test macro, here's issues we may encounter. I had heard through the library implementer grapevine that this feature might break user code. But apparently those initial reports were not as bad as feared. The other standard libraries have implemented this, and I haven't heard of the world exploding. So I don't think that there will be significant breaking impact when we ship this, but we will see. One of the nice things we do is we regularly build and test the STL and the whole tool set against real world code, open source repos. So if there are source breaking changes, we tend to find those earlier rather than later. So the paper is here. And as usual, we like to refer to the actual working draft, which has evolved considerably since this paper was accepted in 2018. So it's helpful to know where variant is. It's hiding in the mega clause, general utilities library. And we scroll down and let's see if I can find it. It's probably right in front of me. Variants. There you go. It's going to be class template variant, constructors. Okay. So it's going to be somewhere around here. We still like to look at the paper to get an idea of what was changed. I sort of skip over all the rationale and I just look at the wording when it's time to implement it. Okay, so this feature. The thing about skipping over the rationale is that it's nice sometimes to understand why a feature is being done. And sometimes it is necessary to understand, like, what is this wording trying to achieve? But from an implementation point of view, we just need to make sure that the standardese is actually being translated to code. So a lot of times for library implementation, I just say, okay, what's the wording? Nothing else exists to me. Okay, so we've got variance constructor from some arbitrary T that does perfect forwarding. There were some very interesting standardese here that said, build an imaginary function fun taking TI for each alternative type TI. These are the alternatives that the variant could be. As background, variant is essentially a type discriminated union that is more type safe than just using a union. So you can say, I have a variant of, int double and const star. I don't know which one it's going to hold at runtime. But please let me store one of those and then retrieve it if I'm correct about the type. So this had the interesting question of, okay, you're going to construct a variant, but what if you have a variant of like int and const star, and you can construct it from a short. Ideally you would like to construct the int member of the variant. Because short is convertible to int and it's not convertible to const star. But how do you even explain that in standardese? So that's where this relatively unusual wording, build an imaginary function comes in. I'm also sort of explaining my understanding of variant. I did not implement this. This was implemented by Casey Carter, who's also watching this. So I have reviewed the code. I have seen bug fixes. But the metaprogramming is very complicated, and hopefully I will be getting everything right here. So let's see, JB type this term as followed, build the imaginary function for each alternative, and now this is being added. Previously, we just built the set of imaginary functions, and then say, okay, attempt to perform overload resolution for calling these imaginary functions like fun taking int, overloaded with fun taking const star. What would happen if I tried to call that with a short? And then if we get a unique function selected by overload resolution, it would say, hey, you actually want the int here. So it's saying that the constructor variant is going to behave like overload resolution, but we need to do it entirely with library tech because the core language does not directly support this sort of very unusual thing. And now this is being added, for which an array of alternatives TI brace initialized with a single element of type forward TT that has to be well formed for some invented variable X. And there's an additional restriction that if you have a variant where one of the possible members is CV qualified bool, constant volatile bool, then we require that the input be bool as well, because it would be very strange if you could initialize a variant bool from like 1729 that would sort of smash the int down to bool. And although the core language permits that, we kind of look at that with some skepticism. So I believe that's why that restriction is there. So this well-formed bit, I see, and there's a helpful drafting note. It verifies whether there's a narrowing conversion. The standard has a concept of narrowing conversions that was introduced in C ++11, where brace initialization forbids conversions that could lose data, like narrowing from long to care. That's a narrowing conversion because you could lose, the whole range of possible inputs. Similarly, from double to int is considered a narrowing conversion. There's a list in the standard. If you search for narrowing, actually, maybe I can open up another standard here. It's only 5 megabytes. What's taking you so long, PDF reader? Okay. Narrowing conversion. It's one of the phrases of power that is at least relatively uncommon, so it's pretty easy to find. Here we go. So it occurs in 945 list initialization because it keys into the brace init wording. And if we scroll down through many numbered bullets, we should find it. Here we go. Paragraph 7. A narrowing conversion. The standard italicizes phrases when it's introducing them as phrases of power. Is an implicit conversion from, and then it lists a whole bunch of possibilities, like going from any floating point type to any integer type. That's considered narrowing, and a whole bunch of other cases. And so then the standard has an example of what could be well-formed and what would be ill-formed because of error. So like here's a good one. This is attempting to brace init. I can actually maybe make that a little bigger. This is attempting to brace initialize a float from an int. This is actually narrowing because the range of int goes up to, on our platform, 2 to the 31 minus 1. And that is far beyond the range that float can represent losslessly. Float stops being able to exactly represent integers after, I think, 16 million. So that's why that's considered narrowing. So interesting side note here is that compilers kind of treat this, some compilers treat this as a guideline rather than a rule. When you're trying to brace initialize values, even though the standard says this stuff is ill-formed, I think 2 out of 3 compilers will just issue a warning. We can actually check. This is not technically related to the PR, but it is very useful to know of general interest. Let's see if this will load. A bunch of JavaScript. Okay, good. I've got GC and Clang. Okay. So let's just have an int main. Let's have an int x. It doesn't matter what the value is because the rules for narrowing conversion don't care about the value as long as it's not a literal. They just care about the type. In this case, x is an int. Nothing in the language could possibly care what x was initialized with. And then later, if we try to make a float f, brace initialized with x, and just in case anybody's going to warn that it's unused, we'll silence it here. And here we go. So there's a difference in opinion between these 2 compilers. If you look at Clang is on the right here being very strict. It's saying error, non-constant expression cannot be narrowed from type int to float in initializer list. Interestingly, Clang is saying that this is actually a warning that is being treated as an error. And then it explains, hey, here's how you can, cast and silence this warning. GCC says, hey, we've seen a lot of this in existing code. And in particular, although brace initialization of a scalar like float was added in C++11, there was a lot of existing brace initialization of arrays, going back to C and early C++, where these sort of narrowings happened. And rejecting them all seemed like too much of a break and change for some compilers. So GCC admits a diagnostic, but it's only a warning. And it says, whoa, W narrowing, you're narrowing into float. So technically, you can look at this and say, yeah, it conforms to the standard because it issued a diagnostic and, yeah, proceeded to compile the code. But compilers are always allowed to do that. But it's definitely being less strict than Clang here. I think we can switch over to MSVC and see what it says, since we only want to see compilation. Let's select, latest. That sounds good. And this option will not work. Let's give it like this and see what happens. Oh, so MSVC actually emits an error. It says error, conversion from int to float. So it's actually interesting. For some reason, I had thought that, only Clang was strict and MSVC was emitting a warning. But hey, MSVC emits an error. I think it may emit a warning in some other cases. I'm thinking of aggregate initialization. But in this case, it's just initializing the scalar float. So this is actually good news for us. It means that if we attempt to brace initialize, and we could check, the actual array syntax that the paper is using, but we can depend on MSVC and Clang to give us errors, which is good. And if not, it's the compiler's issue. Well, we'd have to work on it, but morally, it would be the compiler's issue. Okay, so we need to use this brace initialization of an array with a single element to see whether it's well-formed, and this will test whether it's narrowing. And the drafting note says we need to use this make an array of one element syntax, because if you didn't have that array bit, things like vector that overload their constructors for initializer lists could cause confusion. And then the variant assignment operator, which is the same sort of deal. You could have a variant of int and const star and assign it a short. This essentially needs to construct one of the alternatives, even though it's an assignment. Exact same wording is applying. So it's really, we're going to have some sort of fundamental tech that's going to look for the narrowing conversion, and then we're going to apply it to both the constructor and the assignment operator. Okay, so since that was the paper that was voted in, I'm going to do a quick double check to make sure that none of this wording has changed interestingly in the latest working paper. This is actually the C++23 working paper, 4878. So here we go. Here's the perfect forwarder. And here's the new wording. And the wording has changed. So before, what was applied had this directly if T is CV bool. And now, let's see, I don't even see the CV bool. Was that removed at some point? Very interesting. Yeah, here's the well-formed bit. Okay. Okay, good thing, double check this, because we don't want to implement stuff that was ripped out of the standard. Where's the assignment? I'm assuming this was also changed similarly. Here we go. Yep. And then nothing about bool. Okay, so something changed here. So there's two ways to, well, okay, there are at least three strategies to determine like what changed in the standard. The fastest way is if you're looking at a core or library issue. Casey, I'm sure, is giggling because he knows exactly what changed and is watching me rediscover this. Don't spoil it. I want to find out for myself. So the fastest way when I'm like, okay, what changed in the standard is I'll look at the table of contents, and let me turn off my video because my machine's overheating. Nope, yes. Hi, Casey. Bye, Casey. And my video. Okay, good. Okay, so we load the table of contents for the standard library. So there's a URL here. So you're supposed to get GitHub.io lwg toc.html. And what I'll do is, this is actually indexed by section, but often just searching on the title and the section is sufficient. So in this case, the section that we're interested in, it would mention the constructors variant.cdor. So I look at the stable name, nope, not cdor.variant, variant.cdor, and see if any issues were voted in. Library needs to specify what it means. No. Clarify variant construction. That's recent-ish. It's interesting, although it just says clarify. The form initialization for in-place constructors, no. Variant copy constructor, no. Variance copies must be deleted instead of disabled by Sphene, no. Variant default constructor, no. Surprising variant construction. Well, I don't like to be surprised. Let's look at this. Oh, and these little eye links here, which I really should click on, this takes you to the entire list of resolved library defects, which is huge and it takes forever to load. If you click on the eye, it takes you to the individual page for that issue. The same as using the wg21.link URL shortener takes you to. Okay, this looks good. Looks like we have some Reddit-driven development. A user has an example involving convertible to bool. This is affected by P0608, which is the paper we're implementing. So we found the issue. And this was actually resolved by another paper, a core working group, motion 5. Interesting. This is the core working group. Oh, they moved it into the core language. This is converting from T-star to bool should be considered narrowing. So let's see, was this voted into core and then it removed the library wording? So the applied wording from this paper modifies the core wording. Everything below clause 16 is core. So this is explaining, trying to initialize a bool from meow is narrowing. And then they rip out the corresponding wording in the library standards. So this was not recorded as a patch paper in our issues because it was actually the core working group that moved this paper. And when we, at the end of each meeting, we try to figure out, okay, what changed in the standard? Let's go file some issues, track it. We only look at the stuff that the library working group votes in. So this one was radar stealthed, and this is actually good news. It means that we don't need extra library tech. We get the core language / compiler to do our job for us, which is definitely the best. Okay, so that's good. So that was technique 1. Just do a search of the library list, and hopefully there will be an issue if something changed. Sometimes that doesn't turn up what happened. So the second technique, which is not nearly as quick, is the sources for the standard itself are on GitHub. So you can search for GitHub C++ draft. This will take you to the repo. And then combined with a little bit of knowledge on how the standard internally is organized, you can click on source and then find the right LaTeX file. For example, variant would be in the enormous utilities.tech. And then once you click on that, you can use git blame to try to backtrack where a line of the standards changed from. Oftentimes there's like editorial cleanups and stuff and other features, so it can take a while to sort of do source code archaeology, standard archaeology, but this can often find where something changed and why. Sometimes that's not applicable either because the change happened before the CS+ draft moved to GitHub, or just git blame is just taken way too long to find what you're interested in. So sort of at least the ultimate technique I found is to binary search every standard draft. So I've locally saved every standard draft because downloading them all takes forever. But you can do this just from the web itself. It's helpful to have a list of every draft that was the standard. I don't have a convenient way to get that other than by manually walking the linked list, because every draft names the previous draft at the top. It's like up here. Yeah, 4878 supersedes 4868. So if you happen to have every standard draft saved to your hard drive, then you can just do a binary search for, okay, where did this weird wording appear? And after 10 or so jumps, you will find at least the working paper where it changed, and then often it's possible to go look up in the WG21 website, what was the editor's report for that particular standard, what motions were voted in, and then you can track, okay, was it a paper? Was it an issue? Was it just some editorial thing? That has worked several times in the past for me. It is time consuming, but having all those drafts saved has definitely proven useful, especially when you need to do archaeology going back to, 2007 or something in the early days of CS+OX. If that doesn't work, then usually you just have to go ask the people who voted stuff in, hey, why is the wording the way it is? Okay, so now we know why that bool stuff is not there. That's really good news. So we just need to do this brace initialization stuff. Okay, so this is the wording we're trying to implement now. Let's see if I can collapse this. Okay. So TIX square brackets is braced for TT is well formed for some invented variable X. Okay. So now let's go look at here. I suppose I could actually, oh, look, statement reply had commented here. Thank you. That 1957 modifies part of the wording. So I should have just scrolled down a bit and I would have found this. I will give that a heart. Okay. And I may have given it a thumbs up. No, Casey did. Okay. Let's go look at the PR now. There's apparently some possible compiler issue. Our contributor FSB 4000 had also looked at some of that. So we may need to analyze exactly what's going on here. Let's look at the code. Okay, so we're going to alt click on the chevron to just look at the files. So we've got 29 lines of product code change. That's really good. We got one added test. We got a change to an existing test that's derived from libcxx, but it's in our test directory. And then a newly added test. So I like to look at the easy stuff first. Here is the newly added text, newly added test. First, I want to make sure that the file name is correct. I do want to propose a renaming of the test, although the original paper said a sane variant converting constructor. In this case, I think I'd like to record it as just improving variance converting constructor. We don't want to, always, use the paper titles as voted in. Okay, so I think this test is probably the easiest one. Rename this test to although the apostrophe is problematic, we'll just say improving. Maybe improved, because that's an adjective. Okay, can we rename this test to improved variant converting constructor? We could add assignment in there, but then the file name gets long. We actually have a, this is something that could be useful for other OSS repos. Long file names are at least my bane. Whenever I see bugs caused by, Boost or some project has like 20 trillion directories, and you check this out to something longer than, C:\\x, and that overflow, Windows admittedly small max path of 260. It's just such a headache, and it's not really productive. So to avoid such issues in the STL, part of our validator, which is just a C++ program that we compile and run for every commit. One of the jobs this does, in addition to looking for non-ASCII characters, trailing white space, and things like that, is it looks for the path length. Let's see, where do I print that? I guess it's too long. Yeah, here we go. We look at the path length and we just apply an arbitrary limit. If the relative path in a repo, in the STL repo ever exceeds 120 characters, we're like, why do you have a path greater than 120 characters? This is getting a little bit risky. This was semi-arbitrarily chosen to sort of match our column width. So,
Stefan, can I interrupt you?
Yeah, go ahead.
I think Casey has his hand up.
Okay, go for it, Casey.
Hey, I was just going to ask that you, in your rename comment, that you ask him that you include the proposal number in your suggested rename.
Oh, yes, because I wouldn't want
it may not be obvious to them that that's what you mean, even though it's obvious to me.
Yes, thank you. I was taking a shortcut there. Let me get that. Yeah. Let's see, edit to P. Okay. I'm not adding any typos there or anything. I don't know if I need to explain the justification there too much. I think that's fine. Okay. Okay, so that's our limitation on path links. Highly recommended if you're starting your own open source repo. Don't let users, make ridiculously long paths. But yeah, the testing doesn't need to be too detailed. It's just useful in logs to see, oh, okay, this is something to do with variance constructor rather than just like inscrutable paper number or variant, which is, if you're testing all variants, sure, but if you're testing one specific thing, no. Okay, so tester name, good. The newly added test, got to make sure we've got our copyright and license there, yes. So this, because variant is C++ 17, is, oh, and my brain just fired another thought, but I'll pause that for a second. Variant was added in C++ 17. We're modifying how variance constructors work. That is sufficiently, fine-grained and invasive enough that it would be very strange if this were conditional on standard version. If it were a highly breaking change, we could investigate doing that. But for this sort of thing, as long as it doesn't break too much code, applying it unconditionally is reasonable. And in this case, because variant is specifically CS+ 17, I think we can get away with it. Usually, it's the unconditional changes to our oldest standard mode, CS+ 14, that are the most risky because many users, in fact, an overwhelming majority of users compile code bases in CS+ 14. Variant being newer in CS+ 17 means that A, there's just far fewer users, and B, hopefully they will welcome this change because it hopefully increases the correctness of their code. So this is being implemented, I'm expecting unconditionally in 17 mode. Hence, we're going to use the usual matrix of CS+ 17 compiler configurations. And we got our copyright license there. It's good. We got the newly added test, which I'll look at. Okay, and our copyright license is there. Okay, so the thought that fired in my brain as I was talking about that is we have a newly added feature. So newly added features should be recorded, according to our convention, in our central internal header yvals core.h. There is no change here. The easiest thing to miss during a code review is the missing change. So I'm going to need to add a comment for that. Also, many features come with feature test macros. No feature test macro was recorded here, but let's just double check to make sure that there wasn't one added at some point. So SD6 feature test. I'll get us this page. I like 99% sure that there is no feature test macro for this, but I'm just going to double check. So this standing document does not mention the paper number at all. So no feature test macro for this. So only mention in yvals core h. And if it's implement unconditionally, we should mention that there. So I'm just going to scan real quick to see if there is indeed no guarding. There does not appear to be. Nothing says CX620, so it is implemented in 17 mode. Okay, so I'm going to add a comment. Where's a good place? Because there's no place to just add a comment for the whole. Oh, is somebody pushing changes? Refresh. Okay, I don't actually know what changed. That was interesting. We're going to do real live editing and reviewing. Okay, the test change was literally just pushed. Okay. So we need a comment saying that this should actually appear in the has CXX17 section of yvals core h. I was just looking for a good line to comment that on. I don't see a really good one, so I'll just comment on an empty line somewhere. Let's see. Let's copy this. This new feature should be recorded in yvals core h. with the paper title, with the cleaned up paper title from, was it 27? 27? No, if I type a number there, I don't want enter to autocomplete something. Come on. I never, ever want that. Okay. Let's see. I want this. There should be a comment. As this is being implemented unconditionally, it should be mentioned in the C++ 17 section along with the variant, or I'll just say 17 section in sorted order, of course, but I believe Michael knows that this is not the first feature being added. This new feature should be recorded in YVOS Core 8 with the cleaned up paper title from 27. Yep, as this being implemented unconditionally, it should be mentioned in the 17 section. Okay. Good. And no feature test macro, no other test changes. Like you add a feature test macro, you need to add a feature test macro test. Okay, so now I think we can review the code itself. It's only 29 lines, but it's of course complicated template metaprogramming. So new struct is being added. This was belonging to variant init single overload, but now this is being renamed a type apparently, so the tie can be nested. Okay, so that's what's going on there. Okay, so we got struct ugly variant type test build. This is from the standard ti of x empty array is stood for tt. Okay. We have a function with a trailing return type template on C STL class type. This is a static context per function returning trailing return type. So template, okay, underscore construct array. This takes an R value reference to an array of one element of type, and it returns a meta list of integral constant size t idix and type. Meta list is some metaprogramming machinery that is near the top of variant. That's internal to the STL, but used extensively throughout variant. So this is I believe, this is just a list of types, and the two types that we encode in here are this. Okay. So template, static, inline, section context per, explicit CDR only, virtual no. Okay, so all the little decorations are fine. It looks like we don't need no except because it's only for the purpose of type computation. We're never actually calling it. In fact, there's no definition. One stylistic question is, do we really need a trailing return type here? This isn't mentioning anything in the parameters, so it could be put on the left-hand side. We generally do not use trailing return types unnecessarily in the STL. On the other hand, this does kind of make it easier to read because it gets this complicated return type, puts it out near the end. I have no objection to this. I think it's fine. Okay, so template, this is a alias template within the variant type test struct. I was wondering, why is it just named plain type? But that is something that we use. One of the very few non-ugly identifiers we'll use in internal code. Template on C STL class type. I am not exactly a big fan of having both tie and type floating around, but I don't really have better suggestions. But one of the things I like to emphasize in especially template metaprogramming is that, especially before the arrival of concepts, there is really no type system when template metaprogramming, and everything is just sort of enforced at instantiation time. So good naming is especially important to convey the meanings and intentions of what is this type. You know, having a template parameter named random access iterator imbues it with power. And if you just called it, you know, R, it would be much less clear, or worse, it, because that wouldn't even say what it's supposed to be. So here we've got tie and type floating around. So that makes me think about naming, but if I don't have a better suggestion, I won't mention it. The standard itself is also using T and TI, so it's certainly not blameless. So the type being computed is we try to call construct array, and we give it explicit template parameters because they are, in this case, because we're giving it braces, they can't be deduced at all. So we give it IDEX and type. It's very good that these are the same. One thing that I really do try to be strict about is, even if I don't really have better suggestions for a name, as we sort of trace through, template X calls template Y, instantiates template Z, the names of template arguments as they flow through this chain of templates should ideally be the same at every point. We shouldn't have a tie become a type, become a ranit, become so forth, unless like we're clearly moving to a different region of code. It's the easiest if the type name remains the same, and especially that they don't like dance around and what used to be type becomes, meow, and other, woof becomes type, you don't want to get that mixed up. So here I'm very happy to see that IDEX and type are literally named the same. One less thing to keep track of. And then this tie is the T, so that's good, that the user is giving us. We make a decal val, so this is unnecessary. We make a imaginary object of type tie and then put it in braces. So this is implementing that wording. And then instead of trying to make a variable, which we can't really do because that's a statement, we're calling a function that takes a temporary array. So this is implementing the standard ease, even though it looks different. The one bit is that decal val, the way it's specified, forms R value reference T. I've just memorized that from the declaration of it in the utility header. So when you call decal val, you never need to also apply an R value reference. It's simpler if you don't, because that way you're just looking at fewer refs in the code. And then we know as STL implementers that when we see decal val tie, we mean an R value of type tie, assuming tie is itself a an object type. If I say obviously, but it's not obvious. If tie is a L value reference type like int ref, then decal val of tie is decal val int ref, and that's an L value being returned. So getting rid of that R value reference avoids confusion. We conventionally say, I don't need to repeat stud. Actually, I will repeat stud, same principle as what Casey had mentioned. Stud decal val tie as it forms on, or as it, I'll say R var if it's deep, as it already applies add R value reference T. Yeah, we can actually see that. I can show you in the work and draft. It's above in the mega utility. Function template decal val, the imaginary thing. Add R value reference T. This alias template does nothing if it's void, but otherwise it adds an R value reference. Okay, so I spelled that right. Thus, the convention, or therefore, any occurrences, I won't explain it. I'll just say it's unnecessary. Otherwise, I would be here explaining the standard forever. Okay, so this is looking good. Because the scope of tie and type is literally just these two lines, I'm not too worried about it being confused. Like, let's see. The one thing is it is kind of weird that the tie gets added in the middle, but the user or the usage of this doesn't care about the internal construct array. It only cares about type. And because it's all ugly, we're not really strict about, oh, this should be private or something. We just, rely on the ugliness. Tie and type are consistently used below. I hate to ask for it, but it is strange that the standard says in the order TI is the ith type in the variant, so that's IDEX, and then type is the type in the variant, and then T, the user type in question, the one that's being given to the constructor, that appears on the right-hand side. So structurally, I would expect the order to be IDEX type tie, In fact, that's the order that they appear here too. Although I'm not concerned with that. I'm concerned with like, what does it look like in the standard? It's weird that IDIX and type, which are paired together, then get split with tie in the middle here. And it's not achieving deduction or anything. I think that is confusing. I'm just scrolling down. It is, it's because it's internal only. It's sort of ours to change. I guess it's the usage of variant type test. And then variant type resolver is how it's used. I think I'm going to ask for reordering here. Yeah, again, IDIX and type, it's sort of simpler if we just concatenate tie at the end or append it. Yeah, I'm going to ask for reordering. It's weird to have tie injected in the middle, unless there's a very good reason. Okay, so where to add this comment? This is the first occurrence. Okay. The standardies being implemented mentions TI, the ith type in the variant, followed by T, the user, I'll just say the type, or the constructor argument type. Therefore, or here, IDIX and type, actually, here and in trying to express my thoughts in a sort of comprehensible manner, in construct array, IDIX and type represent TI. It is potentially confusing that tie, which represents T, all these T's floating around, appears in the middle of IDIX and type. I believe it would be better if these template parameters appeared in the order IDIX type I think that's clear, even though you got size T and class there. Yeah, I think I've explained that middle bit there. Then I need to say this also applies to variant type resolver. I think that's the only one it applies to, and of course all the usage. This also applies to variant type resolver immediately below and their uses. Okay. The standardies being implemented mentions TI, the I type in the variant, followed by T, the constructor argument type here in a constructor array. IDIX and type represent TI. It's potentially confusing that tie, which represents T, appears in the middle of IDIX and type. I believe it would be better if these template parameters appear in the order IDIX type tie. Okay, whenever I have something complicated like this, I try to make sure that I'm not also like reversing something or negating something, which would just be incredibly confusing. This also applies to variant type resolver immediately below and their uses. Okay. Yeah. And I'll say, as a bonus, but not the motivating reason, this matches IDIX type tie, the order in which they appear in the decal type below. Okay. I won't say below. I'll just say the decal type on the next line, rather than far below. The decal type on the next line. Okay. Okay, ordering. Next, so after defining the struct, we're going to define a convenience alias template. How did we ever live without these? Going to reorder these: template, IDIX, type. The variant type resolver is we use type name to disambiguate. We've got a nested template because it's an alias as well. And yeah, we can reuse type there. That's fine. Okay. So that's good. We're then only going to see variant type resolver below this. Okay, so that explains what was going on here. That's why it becomes type. We got template, size to edX class type, variant init single overload. So this is the stuff that was constructing the imaginary overload set, I believe, or part of it. Yeah, this corresponds to a single imaginary overload. So previously, we used to have a conversion operator to a function pointer that would take a given type and then return information saying, hey, which TI do you correspond to? I believe this is because you can have a variant of like double, 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 where they're distinguished only by the index. So now this is changing. This is now an alias template for a given tie, which is now by convention the user's constructor argument tie. The F tie is the variant type resolver, which is going to generate the meta list info that we want, the TI essentially encoded, which is going to correspond to this. Okay, that's good. Of idx tie type. Okay, so this is making sense. And then instead of having a conversion operator to function pointer, we're going to have an imaginary, because it's not really implemented, function call operator that takes, interesting, it takes tie-ref, perfect forwarding. It also takes type. I don't understand why this is here yet. And then it returns f tie of tie. Here, I don't understand why the trailing return type is being used, because this is not really bulky. It is technically consistent with this above. I wouldn't have written it this way, but it doesn't really have any clarity downside, so I'm not going to ask for a change. Okay, so I don't understand why this is happening here. Okay, CP learner, who's a contributor, is okay. He found a workaround. Possible EGG issue. Okay, it would have been better to repro the bug, create an isolated repro, and then report it. Actually, no. Here he thinks that EDG is conformant. Oh, Clang and MSVC might be bad. That's very interesting. So it would have been better to reduce and report a Clang and MSVC bug. I'll mention that here, but I won't require that to be resolved. In the future, if Clang MSVC compiler bugs are suspected, it's a good idea to reduce and report those bugs as issues encountered in one part of the STL will commonly occur again, as we tend to write similar code patterns. It's not necessary in this case, but something to keep in mind for the future. Something to keep in. It's like in that episode of The Walking Dead when, spoiler alert, if you ignore a zombie, it'll go, attack your friends later. Okay, so we've got this operator. I still don't understand why type is being passed here, because it's part of the variant init single overload above, but we'll see about that. And it's interesting because the idx is not here. So if we have like, double, 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 these would just all be double. Okay, we'll see about that. So then later we've got our variant init overload set that derives from a variadic list of base classes in its single overload and now drags in all of their operators. It is surprising that the syntax works. Okay, so now they're overloaded in all these various type, and so forth. Okay, And then we've got variant in a helper. This is trying to determine, could you possibly call this thing? So that's what this void t spine is doing. We're getting some wrapping here because new decal val is being added. Okay, so this is where that extra argument comes in. Start variant in a helper. Okay, same comment for decal val. I'm going to have that. This is all the same. So this argument's being added. Okay. And the rest is the same. Okay. So really it's decal val tie being repeated twice. I don't understand what that second one's doing, but oh, it might be, is it just verifying that it's valid at all? Okay, I've got to see. I'll say same comment about decal val tie. Okay, so what is going on here? Why, if we're being asked, here's a tie, what are these types that are being given? Okay, helpful comment. Perform overload resolution to determine the unique alternative that should be initialized in variant types from an argument expression with type and value category tie. So tie is indeed the user's argument type. Actually, there's 3 occurrences of the decal val tie ref. I'll say that it occurs 3 times up here. Though I don't have to keep repeating it. Occurs twice below. I think it's twice. Yep. Okay, get rid of this. Deduplication. Okay, and then if the void t reports, hey, you know, this is actually going to compile, then we report the type in that meta type list thing. So why do we pass tie twice, essentially? Because these are both going to be tie with that change here. The redundancy may not have been apparent when it was originally thought that the tie ref was necessary, but it's not. Okay, so in the variant init single overload here, originally we only passed tie. And that was the thing that was telling us, can you actually call this, which is best, and then we select the return type. Now that information is flowing through here. And yet there's also an attempted conversion, you know, attempted in the sense of the compiler is going to try to do overload resolution from the user's argument type to the type member of the variant. So this would be like in a variant int double, so forth. Type could be int or double, and then tie ref could be the user's short or whatever. So this will simply ask, are you even convertible to type at all? But it's not going to provide any level of like goodness, because this one is, oh sorry, it's reporting this different kind of conversion than this tie ref. Is this needed by the standard ease? Because this one will verify, does this brace init work? Does the standard ease also require the implicit conversion? I bet you it does. I bet you that's why we've got this. So let's see. Let's go actually back to the standard ease, which is now evicted from my cache. Constructor. Okay. There we go. Variant ref. You build the imaginary function. Okay, the first part, the new code being added, sees if the brace even compiles. And then the second part is the second parameter that I thought might be unnecessary. But okay, this is trying to see. Okay, the expression is well formed. Oh, is the first one not even doing a conversion? So here, this operator, oh, this absorbs anything. Okay, I see what's happening now. Finally learning what's going on here. So the original code that was doing like the goodness of overload resolution, like converting short to int is possible, converting short to unsigned char star is totally bogus and not viable. That's still being handled by this existing argument, which is now the second argument. The first one, which is now, you know, we're adding an extra decal val tie. but that's being passed to a perfect forwarder. This is tie-ref-ref, and this ref-ref is absolutely necessary. What's happening here is this absorbs anything. It's purely being used to compute through the variant type resolver whether this compiles, and if so, the TI and index. So this is checking the validity of this expression. It's instrumental in selecting the right TI and index, which previously we just implemented in this layer, but it's not performing any like goodness check. That's all still happening here. So that's why this is necessary. So this is all good. The order here doesn't really matter to me. It is true that this previously existed, but it's sort of the same way. It would have been equally confusing to me the other way around. I still would have had to trace through what was going on. Okay, so I'm happy with that. And I think once it just says decal val tie, it'll be clear that we're querying type in two different ways, and then nothing else has changed. So nice thing is that because this machinery is centralized, we don't need to go change the constructor and the assignment operator separately. Casey did a really good job with design here. So that's awesome. Okay, I see no other issues here, so that's awesome. Nothing else that would require changes in other part of the code. So I think that's the product code. Let's take a look at the test. Change to existing test. Okay, so we got some workarounds here. This is being guarded for clang. If not defined, double underscore clang. If not defined, double underscore clang. Okay, so we do need to report this compiler bug before checking this in. Okay. Note, we need to report this clang bug and cite the LVM issue here before merging. Okay. And I know that that's what Mike Ruskala was intending, but the note will help us remember. And I'll say ditto below. Presumably they're the same bug, I really hope. Okay, ditto below. Okay, so that's good. Next up. Okay, so new task, got our banner. Also test for P0608R3 converted from T-star to bool should be considered mirroring. I'm glad that the compilers have apparently implemented this before we've had to ask for it. Okay, so we've got inclusions. We'll see if those are all necessary, all present. We've got time check, it's 5, okay, good. We've got a struct double double. It's constructible from a double X, implicitly constructible, so that's fine. Because this cares about implicit constructions. Usually if we have test code, even in test code, I'm like, oh, yeah, that's an implicitly converting constructor. That should be marked explicit. But here, that's the whole purpose. Struct convertible bool from X. The DOR is defaulted. This is not actually necessary. Ask for it. Because like the copy constructor and copy assignment operator are also being generated by default. I will note, but I will say no change requested, just because I think Michael Ruskala might not be aware of this rule. No change requested. Note that defaulting the destructor is unnecessary. It will be generated even if a constructor like copy signature is declared, whereas the default constructor will vanish as soon as any other constructors are declared. Okay. Gotta love all CS+'s complicated rules. Then we have an implicitly converting operator bool that's const no accept, returns the X, okay. We got examples from P0608R3, so that's cool. We got usages of, I probably should be less paranoid about this. I want like side by side here, come on. I finally cloned the STL repo so I can search it if I need to. Can I do some designs? That's actually not too bad for this code. Okay, so we're using, this is my magic trick for making sure that all headers are present and there are no unnecessary headers. I just indent them. We got our variant, we got our string, we got our type traits. Okay, variant string bool is constructible from constructor star. So this will initialize the string. It's constructible from a string R value. If you have a variant of char and optional char 16, you can construct that from just a char 16t. So that's an optional. If you get a variant of reference wrapper, okay, here the wrapping is not my friend. Can I crunch this? Yes. Expandify, yes. Variant of int and reference wrapper double is constructible from an L value of type double. Yep, that's from functional. Float int char goes to int. Yep. Oh, we got EDG bugs here too. I'll make this a general comment. Actually, this is a different test file. Similarly, these EDG bugs should be reduced and reported. So we can cite the dev members. Okay. Here from long, there's a convention I'll mention. In long, int goes to them. Float long double, int will prefer the long. Float vector int, there's use of vector. From int, interestingly, the int can initialize the vector int because it is. That's interesting. Why is that? You can't implicitly convert int to vector int. Oh, it goes to long. Okay, that's good then. Didn't see that there. Okay, stylistic style. We conventionally say long and long, never long int, and long int occurs below. There may be a few exceptions in the variant optional any tests whose sources were derived from LVM tests or libc_x tests, but we are consistent in all other tests and product code. Okay. More things. Variant of float should not be constructible from int. Variant of float and vector int should not be constructible from int. Float and char should not be constructible from int because that's all narrowing. Okay. And then excellent test coverage for nice 57R2. Bool and int is constructible from bool or bitset reference or just variant of bool. That is bitset, but this is a using namespace stood test. So we don't need to say stood. I scrolled too far. This test is already using namespace stood. Occurs below. Yep. More examples. This double struct is constructible from double. That's an implicitly converting constructor. If you have a vector int, an optional int, or just an int, it's going to prefer the int. Okay, the runtime checks are going to determine if we actually get the specific TI, the type with an index that we care about. This is just seeing, are you constructible at all? So far, I've not seen assignable tests, and I'm going to look below for those. Okay, if you just have an optional int, then that will be acceptable. Okay, yep, this is all making sense. Convertible bool, yep. Both conversions from and conversions to. Okay, that looks good. all these compiler bugs. Look at this. MSVC is not the buggy compiler here. Well done, MSVC team. Okay, so we got stackasser, yeah, double should not be constructible from int because that would be narrowing. That's a little interesting. This probably relates to the comments. Why is int considered narrowing here? Because int, oh no, it's any integer type to any floating point type, even though double can exactly represent all ints. Is that right? Let's see. Narrowing conversion, it was 953. No, I'm confused. It was declinant. 935? No. 945. 945. I'm just going to recite digits of pi for the rest of this video review. Okay, where's paragraph 7? 7, a narrowing conversion. Floating point to integer. Or from an integer to a floating point, except where the source is a constant expression. Okay, so the fact that we've got a runtime int is not good enough there. Okay, so that's good. Unsigned int, not to vary in float. Okay, and then actually both EDG and Clang. I'm just gonna drop this and update the comment here. Was it here? Port. Let's generalize this. These Clang EDG bugs and cite the LVM devcom issues here before merging, ditto below, and in the new test file. Note, we need to report these Clang EDG bugs and cite the LVM devcom issues here before merging, ditto below, and the new test file. Okay. Okay, so that looks good. Int prefers, oh no, this is ambiguous because it's not constructible because int, interestingly, is equally convertible to long and long. And there's no rule in the standard that says going from int to long is better than going from int to long. Okay, so now we've got runtime checks for P0608R3. I always like to make sure there's no typos there. Have we gotten all the headers yet? Yeah, and of course we're asserting. Okay, so unless I see new types, we don't need this now. Oops. Okay, so variant string of bool A copy initted from ABC. That should select string. We should get index 0. If we get the 0th element, it should be ABC. This is not necessary. You can compare a string to a string literal. Constructing a temporary string here is unnecessary. We can directly compare to the string literal. And that doesn't affect the correctness of the test or like the intent of the test. A lot of times in test code can do something weird just because it's needed for the test. But in this case, the interesting stuff is happening in the variant, not in the get. Okay, so we got a variant care optional. We're gonna have a Unicode escape for whatever that character is. We're gonna get the optional constructed, and there should be that character. We're gonna get a double, that's pi. Should select the reference wrapper double. Yep. Index 1. Exact equality is okay. Years earlier, I would have said, whoa, that's exact equality on a double. You can't do that. Doubles are imprecise. But now I'm like, no, doubles are, crystalline, bits. And yeah, this is going to round from decimal to binary, but this is an exact binary value. So the quality is totally cool because we're not doing math on it. We're just storing it. So that's awesome. Okay, T1 is a variant of float and int. If you default construct, index active is 0. If you assign 0, that should be the int. Index is 1. Float and long. Index is 0. Again, we got a bug here. If we assign 0, it should be the long. Variant float and int constructed from a char should select the int. ASCII assumption, that's totally cool. Float and long should select the long with, if you give it an int of 0. Float long double, again, select the long. And yeah, here this comment should also be updated, but I'm sure Michael will get that. Index 2. float int and long from a char. This is unambiguous because I believe the char will promote to int, and then it's an exact match, because we're passing by value. And whereas converting to long would be a conversion. Whereas we saw with the int to long and int to long, those are both conversions. They're equally good, but this is unambiguous, and all the compilers agree. Okay, so that's good. These are just being named alphabetically, so that's fine. Okay, test variant constructor P0608R3. This is the bool thing. Bitset for a bitset is 0101. A data is element 2, which is the 0. Copy init from a data, which is just a bool. Okay, it's not one of those bitset references, but that's fine. And then it should be, what was this? Is this little endian? I always forget. 0, 1, 2. It must be little endian. Yeah, this is bit index 0, so it's the 1. Okay, that's good. B bitset is the same value. I don't actually know why we need 2 bitsets, but I guess it's okay. B and B2, we're gonna get 2 different bools. This is just making sure that we can get. These are the same types. Like this is testing it like literally the exact same thing, the 2. I think these could just be unified. Like at first I was like, okay, you're gonna go do something different, so it's fine to have a identically named bit set, but I think this could be collapsed. It should just be, in fact, just this is fine because this supersedes this. This is testing the second element. Oh wait, I see the difference. Sorry, I'm confused. This is testing construction from a bool, an actual bool. This is testing construction from a bitset reference, which is not a bool. Okay, it just selects the bool element, so that's fine. That's good. Okay. Test variant constructor, more tests. Variant, char, int, float, bool, vector bool. If you give it a true, should be a bool. Okay. Convertible bool initialize from true. Love those braces for a temporary. Char, int, bool, false. Okay, that should select the convertible bool. This is a fancy way of spelling false. Okay. Convertible bool should be convertible to the bool. Yep. And bool int. Okay, so this is all good, except that there are no tests of the assignment, which I would like to see. Let's make sure that all the functions were actually called, because it's easy to define a function and forget to call it. You got support code here. We got test variant constructor 1957, and the more tests. Okay, so all the functions are being called, but we just have no coverage for the assignment. We should additionally have test coverage for the assignment operator. It doesn't need to be nearly as comprehensive as the constructor tests, since the same code path is being used. We just need to verify that the assignment operator is activating the new machinery. Yeah, which is this is a common form, because like, yeah, you could spend eons testing like every possible, combination, permutation of the entire cross product of constructor and assignment operator and so forth. This occurs a lot in functional type testing. Often what we'll do is we'll intensively, and I did this in the invoke test. You intensively test the core machinery. Like think about every possible way that it could go wrong, all the weird things that users could do with, structs that are convertible to function pointers that are, ambiguous. And then once that core machinery has been absolutely comprehensively tested, you just do very quick spot checks of all the places that are supposed to use that core machinery to make sure, yep, you're using the invoke protocol, or you're using the variant converting constructor, brace init, narrowing detection. So if you get that right, basically you must be going through the same code path. And we can do that without, any real fear of loss of coverage, as long as it really is unified. In this case, there's nothing special about the assignment. So we expect all of this to carry over. We just need a few tests, and then that should do it. Okay, I can't think of any other test coverage that needs to change. If libcxx tests were affected, they would be failing. So that would be reported. Apparently, that's not yet the case for LVM project. We've already got this update for the compiler bug. I can't think of anything else. So I think that is a review. I will request some changes. Okay. And we found some good compiler bugs in compilers, which is great. And we'll have to, and I see the tests have stalled here. This must be our sporadic hang that we're looking into. Yep, we stopped hearing from agent build. We think it's because our tests are so stressful that they consume all the CPU. I will activate another test run for that thing that was just pushed. Only maintainers can do this, so I'll type the manage comment. Okay, so that brings us to the end of our code review, 10 minutes before our scheduled end. Do people have questions about the various topics we covered or things that I missed? As I wait for the Azure Pipeline bot to respond, I guess I can close this. Yay, thanks Azure Pipeline. I like to hide this noise.
I don't see any additional questions in the chat. I think Casey was providing some additional background and spoilers. There was a recommendation for, I think, better names for those template type parameters, but that's in the comments. But then otherwise, Cameron's just hiding because we whispered compiler bug. Or MSVC bugs specifically, but not nearly as many as other compilers.
Yeah, and actually in this case, I saw no workarounds for MSVC bugs. It was all Clang and EDG. So in this case, it appears that C1XX is getting all of this right, which is awesome news. All the compilers of bugs, like they have a really hard job. We have it easy in the libraries.
Yeah, otherwise I don't see anything unless anyone else just has things on their mind.
Okay, cool. And if you do think of something, always feel free to, leave a comment on the PR itself. Casey will be doing a more thorough review of this later as well. So cool. Well, thank you everyone for watching.
Yeah, thank you. I will stop the recording.